Welcome to Lecture Online, and now we're going to talk about how we measure things in the universe. Now, you know the universe is a very big thing, so we need very big yardsticks in order to measure things in the universe. Meters, miles, kilometers just don't seem to make do in this huge universe of ours. So what we have instead is we have three very unique units that we use in astronomy. One is called the AU, or astronomical unit. I should probably write that down. The second one is called the light year, and the third one is called the parsec. And so let's go and explore what these three measurement mechanisms are. So the first one is fairly straightforward. An astronomical unit is simply the distance between the Earth and the Sun. It's about 93 million miles, or about 150 million kilometers. So whenever we talk about things in our solar system, we tend to think of them in terms of astronomical units. For example, the distance from the Sun to Jupiter is about 5.2 astronomical units. So if this is Jupiter right here, the distance from there to there is about 5.2 astronomical units, which then automatically means it's about 5.2 times the distance between the Sun and the Earth. And if you round things off a little bit and say it's about 100 million miles, then 5.2 astronomical units is about 500 million miles. So it's about 500 million miles between the Sun and Jupiter. Now the average distance I say is because Pluto, of course, its orbit is very elliptical, and sometimes it's as close as about 30 astronomical units, and sometimes it's as far as 50 astronomical units. So the average distance for Pluto is about 40 astronomical units, which means it's 40 times the distance between the Sun and the Earth. So that gives you a pretty good feel for how far that is. That's almost 4 billion miles, so that's quite a distance out. Okay, the next measurement that we use, and this is probably the most commonly used throughout the universe, or not throughout the universe, I should say, but for measuring things throughout the universe, is called the light year. It's the distance light travels in 1 year. Now, the name is a little bit odd because when you think about the term light year, you think about time. A year is a unit of time, but yet a light year is actually a unit of distance. It's the distance, and this is the key word, it's the distance light travels in 1 year. So how far does light travel in a year? Well, it turns out light travels, the speed of light, we use a small letter c to indicate that, the speed of light is 186,000 miles per second. So that's quite a ways in 1 second. Also, in SI units, it's 300,000 kilometers per second. So 300,000 kilometers is 7.5 times around the world. Now, of course, light doesn't travel in a circular path, but if it could go around the Earth 7.5 times in a single second. So that's moving along quite fast. So from the Earth to the Moon, it takes a little bit over a second. And for the distance between the Earth and the Sun, it takes about 8 minutes and 20 seconds. Wow. So if light can travel between the Sun and the Earth in 8 minutes and 20 seconds, how far does light travel in a whole year? Imagine 186,000 miles every single second, and imagine how long a year is. A day alone is 86,400 seconds, and then a year is 365 days. So how far does light travel? Well, let's find out. That's why we need a calculator. So the distance, so 1 light year, is equal to, let's see here, that would be 186,000 miles per second. And then if we convert that to hours, so we have 60 seconds per minute and 60 minutes per hour and 24 hours per day and 365, I guess in a quarter on average, it's 365 and a quarter days per year. That's why we have a leap year every 4 years to account for that quarter of a day every year. So if we multiply these numbers together, what do we get? 186,000 times 60 times 60 times 24 and times 365.25 equals, and we end up with a distance of 5.87 trillion miles. Now, if we do that with kilometers instead of miles, what do we get? So we get, well, divide by 186 times 300, we get 9.46. So this is 9.46 trillion kilometers. Wow, that's quite a distance. The speed of light, let's see, if it takes about 8 minutes to make it between the sun and the earth, then how long does it take for light to reach Pluto? So since Pluto is about 40 astronomical units away, so we take 8 1/3, so 8.33 times 40, that's 333.2 divided by 60, it's about 5.5 hours. So if light travels from the sun to Pluto in 5.5 hours, imagine how far light can travel in a year. So it's quite amazing. At least I think you have a pretty good idea. If you want to round it off, it's 6 trillion miles roughly for a light year, or almost 10 trillion kilometers. That's probably an easy way to remember it. And finally, the parsec. Now, parsec is not as commonly used, but you'll see it in a lot of textbooks, and there's a very specific reason for that measurement to be there. And yes, some textbooks do like to use the unit of parsec, so we need to know what it means. Imagine that we have the sun here and we have the earth. Let's say there's a star far away, a few light years, 5 light years, 10 light years away, something like that. And then there's stars, of course, much farther away. And it turns out that because the earth goes around the sun every year, we will have a different vantage point of looking at nearby stars relative to looking at faraway stars. And what happens is they appear to move in the sky just ever so little. So what happens is, if we look at this star right here from the earth, and we draw a straight line all the way to the very far stars back here. So we have, if we take a picture of this star will appear to be, of course, over here among these other stars. So let me make a red dash right there. Okay, so that's where the star will appear. In astronomy, when we look at stars far away, we really don't know how close or how far away they are. They just appear to be there. And so even though one star could be much closer than another, we have no idea of knowing that just by looking at them. So let's say we look at the very same star 3 months later. 3 months later, the sun will have moved on its path around the sun 1/4 the distance. And so now the earth is over here rather than over there. Now looking at the same star, notice what will happen. It will now appear to be over here instead. So that star will appear to move. If we take a picture of the sky 3 months later, the star will now appear to be in a different place relative to the stars that are so far away that they don't move at all relative to the motion of the earth. Now, it turns out if this angle right here, this angle, let's call this angle theta, and this angle right here, let's call this angle theta. If that angle is equal to 1 arc second. Now, what is an arc second? Well, it's an angle that is an angular measurement of 1 second, or of arc as we call it. And so we'll talk about that a little bit later, but let's say that 1 arc minute is equal to 1/60th of a degree. And 1 arc second is equal to 1/60th of an arc minute. Kind of like there's 60 seconds in a minute and there's 60 minutes in an hour. Well, an arc second is a measure of angle that is 1/60th of an arc minute, and an arc minute is a measure of angle that's 1/60th of 1 degree. That means that 1 arc second is 1/3600 of a degree, a very, very, very tiny angle. And yes, we can measure that. And so if we then measure an angle here of 1 arc second of the relative motion of this star over here relative to the stars far away, then we know that this distance is equal to 1 parsec. So 1 parsec is the distance of an object that appears to move in an angular change here of 1 arc second if the distance is 1 parsec away. And what is 1 parsec? Well, 1 parsec is equal to 3.26 light years. All right, so since a light year is about 6 trillion miles, 3.26 light years is about 20 trillion miles. So if a star is about 20 trillion miles away, and the Earth moves through 1/4 of its path along the path that it goes around the sun, then you can see that when the angle here is measured to be 1 arc second, we know that the distance then is about 20 trillion miles, 3.26 light years, what we call 1 parsec. So those are the 3 kind of measurements that we use in astronomy to measure distance. We have this astronomical unit, we have the light year, and we have the parsec. And you'll see all 3 of them in typically any astronomy textbook.